Okay, so welcome students. So this is our uh, lecture on subspace. So this lecture is delivered for BLED courses. Okay, so subspace we are going to study. Subspace we are going to study. So what is a subspace? So if we are given V is a vector space and W is any non-empty subset of V. So W is any non-empty subset of V. Then W is said to be subspace of V if W is also a vector space with respect to the same compositions. Whatever operations we are having on V must be on W. Okay, so this is the key in definition कि compositions हमारी same होनी चाहिए, operations हमारे same होने चाहिए W पे भी. And if W is also coming out to be vector space, then W we will call subspace of V. Okay, so this is the definition of subspace. Right? So W must have the same operations. So W must have the same operations as on V. Okay, so now you must be thinking, then what is the advantage of defining this subspace? If this is also vector space, then why are we calling it subspace? Okay, so yeah, we will be calling this subspace. In fact, every subspace is a vector space. Every subspace is a vector space, and every vector space is also subspace, as every set is contained in itself. V contained in V. Okay, so now we have two criteria, namely known as one step criteria and two steps criteria. Okay, so first we discuss about the two step criteria. What does it say? It says basically that if X and Y, so this criteria, let me write it here. So this criteria says, first we are discussing two step criteria. Okay, what does it say? It says that if W is a non-empty subset of vector space V. If W is a non-empty subset of vector space V, then W is a subspace of V. This is a notation for subspace. So this notation means W is a subspace of V if and only if, this is necessary and sufficient both. Okay, if and only if, number one, any X, Y belong to W must imply X plus Y, or let's go according to your book, X minus Y must also be in W. Okay, so as we have already discussed that this can be plus also, so you know the reason already. So X minus Y is in W. So this property can also be written as X plus Y belong to W. You know the reason. Okay, Second property is for any alpha belong to F, if alpha is any scalar and X is vector from W, then it must imply that scalar multiplication this with vector must also be in W. Okay, so this is also going to be in W. So whether you write it plus or minus, both will work. Anyway, so geometrically, if we want to see what does it say, first of all, you already know that uh, if x is there, y is there, then first property says that x plus y must also be there in W. Okay, this must also be there in W. And if alpha is any scalar and x is there, so alpha x must also be in W. This will become vector. This will become vector. And now further you can see that this is one vector, this is one vector, so there some must also be there. Hence Wx plus x plus y is also going to be here. Similarly, every vector space, or call it subspace, must have additive identity 0. So minus x is also going to be there. How will you get 0? X plus minus x. So all combinations are going to be there. And in fact, you can check from the following two properties only, you can generate all the properties of vector space. So this is known as two-step criteria. There is one-step criteria also. So what does it say? It says that for any two vectors x, y from W and alpha, beta any scalar, then alpha x plus beta y must also be in W. And yes, of course, from this logic you can see if x is here, then some beta y is also going to be there. So alpha x plus beta y must be in W itself. Okay. So you have to remember the following two criteria. Now, in order to check something subspace, we are not going to prove all the properties of vector space. हमें केवल one of the criteria we are going to use. चाहे एक कंडीशन हम शो करेंगे या दो कंडीशन हम शो करेंगे. Yes, of course, whenever you are going to show something subspace, first we will have to check that set must be non-empty. Then we can proceed further. First we are going to check non-empty and then we will proceed further. Let's discuss some theorems first. And now one question must be in your mind, that if can we have two subspaces or more than in two also? Yes, of course we can have. So if we have more than one subspace of any vector space, then you can talk about intersection and their union also. So keeping this in mind, if you are given two subspaces of a vector space, then their intersection is also going to be subspace. Okay, and since this is going to be subspace, so we have to prove. If something is true in mathematics, we have to prove. If not, then you can always give a counter example to discard. But this is true. Subspace में intersection of two subspaces is always subspace. So theorem. Let's prove this, that intersection of two subspaces is also subspace. Okay, intersection of two subspaces is also going to be subspace. Let's prove this. So in order to prove, पहले हम डिफाइन कर लेते हैं कि हमारा वेक्टर क्या है, वेक्टर स्पेस क्या है, एंड ले लेते हैं कोई भी दो सबस्पेस हमें गिवन है, और व्हाट वी हैव टू प्रूव, वी हैव टू प्रूव दैट उनका इंटरसेक्शन इज ऑल्सो गोइंग टू बी सबस्पेस. So let's assume, let V with the following composition be vector space and W1 and W2 are two subspaces of V. Okay, so the following are two subspaces of V. Now let's see what we have to prove. What we have to prove here, that intersection of W1 and W2 is subspace. तो लिख लेते हैं. It is always better to write what you are going to do. So to show W1 intersection W2 is subspace of V. I am writing in the form of notation. This we have to show. And I have told you students, whenever you are going to prove something subspace, first what we have to check always, non-empty. इस सेट को पहले we have to show that this is non-empty, and then we will proceed further. Okay, so non-empty we have to prove first. So this is obviously, this is very much clear that this is non-empty. Why so? So I'm writing W1 intersection W2 is non-empty because 0 belongs to W1. W1 subspace है तो additive identity 0 is going to be there, and 0 also in W2, as W1 is subspace of V and W2 is also subspace of V, given है. So therefore 0 belongs to W1 intersection W2. तो नॉन एम्प्टी तो हो गया. Let's not call this property, ये तो हमें always करना है. Now I am going to use two-step criteria. Okay, so two-step criteria I am going to use. So first property, let xy belong to this set जिसको we have to prove subspace. मान लिया x और y कोई भी दो वेक्टर हैं इस सेट में which we are going to prove subspace. Now as per the first condition of two-step criteria, what we have to show, that their sum, that means the closure is also going to be here. I am going to prove with respect to plus. Okay, so what we have to show here, so to show finally x plus y must also be in W1 intersection W2, right? And now students, this is given x and y in W1 intersection W2. Let's write down their meaning. So x belong to W1, and because intersection is there, so and y belong to W, x belong to W1 and x also belong to W2. So y belong to W and y also W2, y also going to be in W2, right? X and y both are going to be in W1 and W2 also. Okay, so what we have to show, x plus y is going to be in W1 intersection W2. Okay, so that is already there now. That is already there, that x plus y is going to be there in W1 intersection W2. So this case is very obvious. So therefore now you can write that x is in W1 this error I have made. So y is in W1 and y is also in W2. So that is why I got confused. This error, this printing, let's call it printing error. I got confused. So x is also in W1, x is also in W2. Similarly, y is in W1 and y is also in W2. So now we clearly get x plus y is in their intersection. Why so? So x, y belong to W1 must implies x plus y belong to W1 only, because W1 is subspace of V. So closure property is going to be in W1. Okay, similarly x and y both are in W2. So this implies x plus y belong to W2. Again the same reason, because W2 is subspace of V. Right. So finally what we have got, x plus y is also in W1 and x plus y is also in W2. So therefore x plus y belong to W1 intersection W2. It is always better to give them name. So let's call it property number 2, equation 2, and this is equation 1. So therefore by 1 and 2. So one part is done. Now second part. So second part is, let x be any vector in W1 intersection W2 and alpha is any scalar which is coming from field. So again what we have to show here, students, let's write down. So we have to show that alpha x is in this set which we have to prove subspace. Okay, the same thing, let's write down the meaning of this given, whatever given. X belong to W1 and x also in W2, right? So now alpha belong to F, x belong to W1 and W1 is given subspace. So therefore alpha x belong to W1. Similarly alpha x belong to W2, because W1 and W2 are subspaces of V, are subspaces of V. And now wx W1 में भी है, alpha x W2 में भी है. Therefore alpha x is also going to be in their intersection. Done. So what we have proved, intersection of any two subspaces is also going to be subspace. Okay. Now we are going to think about union. Please think, क्या union भी subspace होगा? What I mean to say, that is union of two subspaces is also going to be subspace. And the answer is no. Union of any two subspaces need not to be subspace. तो अब फर्स्ट वी आर गोइंग टू गिव अ काउंटर एग्जांपल नाउ कि ऐसा क्यों होता है. सी, ऐसा इसलिए हो रहा है दैट दिस इज एन एग्जांपल. इफ यू टेक R2 vector space, and now W1 I am taking one subspace which is x comma 0, and W2 is I am taking another subspace which is 0 comma y. The following are subspaces, students. You can prove on your own. Okay, you can prove on your own. So this is a subspace where first component can be non-zero and here second component can be non-zero. यहाँ पे second component is always zero. Here we have fixed first component is always zero. Okay, so they clearly, please verify at home, clearly W1 is subspace of V, which is R2 here. So let me write R2 then, and W2 is also subspace of R2. And what we have to show that W1 union W2 is not a subspace of R2. तो W1 union W2 किस फॉर्म का होगा? So W1 union W2 is going to be of the form x comma 0 and 0 comma y, where x, y are coming from R. इस तरह का हमारा W1 यूनियन W2 होगा. तो पहले तो क्या इसमें जीरो होगा? हाँ, जीरो होगा, बिकॉज हमने ये थोड़ा ना बोला दैट x कैन नॉट बी जीरो और y कैन नॉट बी जीरो. जीरो हो सकते हैं. सो ये जीरो 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 इज ऑलरेडी देयर. सो व्हाट टाइप ऑफ एलिमेंट्स वी आर हैविंग हियर? जीरो तो है, देन अदर एलिमेंट्स वी आर हैविंग 1 comma 0, 2 comma 0, 3 comma 0, 0 comma 1, 0 comma 2, 0 comma 3. इस तरह के एलिमेंट्स वी आर गोइंग टू हैव इन W1 union W2 together with 0. Okay, so now I claim that this is not a subspace. So claim W1 union W2 is not subspace of R2, because अगर ये R2 का अगर ये W1 union W2 is a subspace of R2, then it must satisfy closure property, which you will not get here. Here in this example it does not satisfy closure property. एक एलिमेंट कोई भी यहां से उठा लो आप other than 0 and pick one element from here also. So as 1 comma 0 and 0 comma 1 belongs to, both are in W1 union W2 होंगे दोनों. W1 union W2 में इस तरह के एलिमेंट्स हैं, but their sum which is going to be what? 1 comma 1 does not belong to W1 union W2, because W1 union W2 में ऐसा कोई एलिमेंट नहीं है जिसका फर्स्ट और सेकंड दोनों कंपोनेंट नॉन जीरो हो. तो यूनियन ऑफ एनी टू सबस्पेसेस नीड नॉट टू बी सबस्पेस. ऐसा इन जनरल हमेशा ट्रू नहीं होता है स्टूडेंट्स. बट नाउ इट रेजेस अ क्वेश्चन that if you allow me to if you allow me to add some extra condition, then can we make union of two subspaces is always subspaces by adding that condition? And the answer is yes, we can always do that. But what is that condition? Let's discuss, and we have to prove also.